Welcome to the second part of the lesson. And in this second part, please note that the name here is self-explanatory because here we have a plain programming. This is object programming because we have a class. And what the difference with the bug 2 example? Welcome back. What the difference between the first version of basic object programming bug and the second one with the specification 2? This is an ingenious way to have two agents, but it's not the correct one. Pay attention. It's an ingenious one. You see, the class is this one. And then we have two instances, and we are duplicating all the calls. Not good. If I have 50 agents, I have to write 50 times the same thing. Okay? Do you agree? This is not a good idea. What is good to be done? The good idea is to move to collections, as I was suggesting, discussing your own works. And this is a many bugs version of the same code. And then we will look to the parallel examples in NetLogo. And in this case, I am starting in a complicated way using a vector. Pay attention. This is always the same. The class is always the same. No difference. Then I start asking to the user, oh, here there is an error. A set of errors. I will correct, but I verify, but this is an error. This is the Python 2. A lot of errors. Please help me in correcting here, 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 here. Here we have to translate the input in an integer value, so we need the int function. And also here, sorry, here, and here. Okay. We ask to the user how many bugs she wants. We ask the dimension of the word, and we ask how many cycles the user wants. Then we create the agents in a generic way. You see, this is repeated for n bugs times, from 0 to n bugs minus 1. But the name is always the same. This is not a cat Felix and then the cat Garfield. It's always a cat, generic. But we don't lose the information because we copy in a vector the different addresses. The first cat, Felix, has been created at the address 1. And we copy in the vector the address. The second one, Garfield, has been created at the address 2. And we copy the address in the vector. Using a vector is not the best idea. We start with a vector, but we will simplify. The vector has been created filled by 0 in the same number of the agents. So we pre-create the vector filling it with zeros. Any question until here? Then the cycle running the time that will disappear at the end because we will avoid to be managing the time is not running a variable upon the agents, but is directly creating an extraction of all the component of the set of the agents, because backlist created as a vector can be also considered a set. So we extract all the elements in this set and we send them the methods of moving and of reporting. Quite clean, not completely clean, but quite clean. Let's execute it. How many bugs? 3. Size of the word, length of the simulation, 2. No, 4. First of all, the creation messages, and then the movement, specifying the agent acting. Okay? Always in the same order, because we are not shuffling the list. We will shuffle it with an explicit function. In the random library, there is a shuffle function, reordering randomly a list, but we don't use it here. Okay? Now, let's jump to NetLogo, and if we have time, we will be back. We are here, this is made. We had to have a short look to the links, because about turtles and patches you are completely aware. Maybe a memory about the links, a memo about the links is useful. NetLogo. Okay. A very complicated operation is to increase the fonts of a window in Mac. Okay. This is the last thing to be examined. This is already has been already used. This is fine. Now a nice NetLogo tool with, we discovered the objects with the ask, moving a unique turtle. So zoom has to be executed from here. Someone of you is using Mac with IG Sierra? No. In IG Sierra, temporary NetLogo works only in English. For other languages, the menu is not defined. Does not appear. So we use a unique agent in a parallel way with the Python example, but now with ask, piloting all the actions of the agents. The time disappeared. The time is no more there. You remember in the first version we had a while managing the time. The wonderful idea of NetLogo and StarLogo authors is that of the forever flag in a button, this one. A step ahead. So if we use simply setup go, our turtle is moving one step, and if we use go with forever, the turtle is no more visible because it's moving too fast. You know that you can decrease the speedness, always too much. Okay. I will remember to do this operation for a parallel version. Let's see immediately. This is the same, but in a parallel version with many turtles. We have a slider with the definition of the global variable and bugs, this one, now set to 50, and another slider with another global variable, the number of cycles, defined to 50. The setup creates the turtles and reset the clock, and then we execute stopping when ticks are greater or equal to the number of fixed cycles. Agents are moving on the screen and are reporting in the bottom part of the window. If you, for debug reason, are using show messages, remember that when you want to run the code in an efficient way with a lot of agents, you have to switch off the show messages because they are incredibly slow. All the interaction with the screen are slow in any language. Now it is interesting to look at the parallel running of the agents. Let me comment this one. So now the code is very, very fast. And let me comment also this stop because I want to look at it a lot. It seems that agents are moving in a parallel way. This is not true. The execution is always sequential. If we decrease the speedness, you see that the agents are moving at each instant, a unique one is moving. The chosen one in the local cycle. Pay attention, this is not a technical problem. It is a problem in creating our models. Because when we manage parallelism, we have to keep in mind this problem. In real life, parallelism is not existing. If I ask you, please keep away, the ceiling is breaking down, a lot of you stay here, because this is demonstrated. People don't pay attention. So, but the other one escaping, I'm not doing that in a normal way. Someone is escaping as first, second, third. Pietro always distracted and deleting what is happening, and so on. So in real life, parallelism does not exist. And within a simulation, one of you want to suggest a simple solution? For any, because the talk is not parallel. Let me add myself to your chairs. Imagine that we are linked in a circle. So this, The order is if you have a person with less on your left, please go away. This is determinism, absolutely determinism, because on the left we are moving, you are going away, you know it is not relevant, the starting point. But if the order is, if you have a person standing up, stand up, the starting point is. If not, sit down, if you are standing up on the left. The starting point is relevant. So what? Tell me. In the simulation, the starting point of the sequence cannot be the key point of the execution. So what are the trick? If you can suggest, I will pay coffee. I want to pay coffee. Coffee for me.
You can do it in a batch.
So splitting. A batch, but we have to split something.
You have to group several agents together, and then you tell them what
No,
to do. But
too complicated.
But you execute it all at once.
You are very able in doing that, but it's quite complicated.
Okay.
It's a batch, sure. But splitting what? Decision and execution.
Oh, yeah, that's what I meant. First you program it, and the execution goes after.
Okay, coffee. You have understood. If in real life the order is decide what to do, but don't act, the starting point is relevant. You have decided, okay, do. And the final effect is always the same. So when we want a true parallelism, perfect parallelism in our simulation, we have to split with interaction, sure, because if the agents are acting alone, it's completely irrelevant. But if they are interacting, we have to split the decision from the execution. Okay? Keep in mind this is a normal way of solving the problem of the parallelism, which does not exist. Maybe in a few years, when cloud computing will be very cheap, currently it's not cheap. Because if you use the cloud on Amazon, you pay a lot. If cloud computing will be completely cheap, you can engage one CPU for each agent. And now you have a situation like real life, because CPU will be not completely parallel, as in real life we are not completely parallel. Maybe this can be a solution. But currently it is not. Here, in this moment, only a unique CPU is serving. I have 4 CPU, my unique one is serving that logo. So necessarily anything is parallel. Is sequential, sorry. Okay? Then we can use a GPU and so on, but it's not our job. This is for you. Have a look to it before making the homework. I switch back. No, I switch back, nothing. I pay attention to this. Okay, question? What? This is very simple. The novelty is the link. What the link is? is a way to add in simulation world relationships. Kill someone. Create link. I am offering a coffee to one of you, to him, the creditor. I will sign an act with you, and we have a link. In NetLogo, a link is an object as an agent and as a patch. This is very important. You already know that. We will use it mainly in the second cycle conversation, where we will be using agents within networks. My idea is that having a network with only simple nodes that do not act is too simple. The networks of social problems, of economic problems, are made by agents, acting and operating. So a good network is a network of agents, both in Python and in Flow. So network analysis alone is a wonderful tool. You will discover it with Martin Kashai. He is one of the best scholars in the field, and he will introduce you the theory of network analysis. But for the application, it is interesting also to use networks to build a system of agents. So links are very important in networking. And what I want to underline is that as you have variables within patches and agents, you have variable within links. So one of you does not know NetLogo, at least two of you. You see here there is a link, has been created from one agent to another. Other is very important because in NetLogo is forbidden to create a link to itself. In Python you can, because as an example, we are producing an object and we have 3 different production phases. And the first and the second are made by me. So I send the object to me. There is a link from me to me. In NetLogo, you can't have an auto link, so this other is fundamental. I want also to underline that this is an example of what? Natural language. Ask Turtle, create link to one of other turtles is English. Is a good choice, complicated for the authors. The trick is create links to needs a unique argument. This is not a unique argument. This is a function. So create link to is put in wait. Technically, this is a push. One execution is push down. One of require one argument. This is not an argument. Create link. One of is pushed down. Push down. Sorry. Other again is not a variable. Is not an argument. It's a function requiring one argument. This is an argument, finally. And now we can pop. This generate a subset of turtles, eliminating us, popping up one off, it receives the subset, it extracts one agent, popping up, creating link 2, it receives one agent. So without parentheses, this is Lisp, because in Lisp all the functions know how many arguments they are waiting for. In NetLogo, we have a special case when the number of arguments is not known. There is an example, the function word. Word is concatenating arguments. Word ABC, where ABC are strings, is creating ABC. If you have only two arguments, you write the word AB. If you have more arguments, you open a parenthesis, you write word, you have any number of arguments, and you close. And in this case, the open-close operation substitutes the a priori known number of arguments. I underline that because as you are more aware of the structure of NetLogo, you avoid errors. These are not trivial constructions. Okay. Now I go back. Sorry. Here, each link, this is the link from 1 to 2, continuing to create links. Here we will have two different links, 1 to 2 and 2 to 1. I can open it, you see the probe, and these are the variables related to this link. If I change the size, in this case the thickness to 1 and the color to red, you see the effect. It can contain any variable. As an example, the strength of the link. My obligation is very constrained. I have to pay the coffee. But if maybe one day or the other we'll offer you a coffee, okay, the probability, the strength will be very low. So we can program also this. Okay, NetLogo is not a perfect environment. I repeat, I use it for prototypes, but we have to know well it because it contains a lot of interesting possibilities. And anyway, is a gift, and each gift we can accept it. Opening our conversation, I was underlining the importance of for each, and here you have an example. If you don't want that Mr. NetLogo changes the order of the agent at each step, you can use for each. For each, sort turtles. For each has an argument, which is a collection. But if you put there turtles, as you call turtles, turtles reorders itself. Not good. It reorders itself. But we sort the content. Sort means to put in order. And the basic sort in NetLogo is to order on the name, the who name, the number. So you will have the turtles in order. Sorter is a very complicated and tricky instruction if you go to the manual because it can do a lot of things in a very complicated way. And you know that if you right-click on a NetLogo name, you jump directly to the help. Not nice, a bit complicated. But I had to use it in a very complicated way, and it works. In this way, the order of the execution will be always the same. Stop. Final step, the homework. Oh, that's not good. In NetLogo, try to modify basic object programming bug upon the frequency of the execution of the messages, so adding random numbers. And with many bugs, do the same, but also try to have a unique one reporting. Always the same or a random one. In Python, try to add the same modification you made in NetLogo, but also try to simplify using append instead of a vector. And I have to show you this step because maybe you don't know it. We have also students that are discovering Python, so it is a good idea to help them. If I create an empty space, m equal empty space. If I write m, the reply is empty space, sure. If I write m dot and I wait, the first function is append. To append means to add at the end. Append object to end. Anything in Python is an object. So I write 3. And now m contains 3. It can be the address of an agent, the self of a given agent. I again append 33, and now m is this one, and so on. M is always a vector, so if I ask m of 1, remember that we start from 0. M of 1 is 33. And m of minus 1, you know it? 33 is an easy way to find the last value because we are going behind and we reappear on the other side. Okay? Don't exaggerate, minus 2, minus 3, stop. And using append, you can avoid to predefine the vector containing the agent addresses. So try to exercise. As always, if you send me at pietroterne@unitoit, which is my preferred address for anything, that of carloalberto.org is for problems, administrative problems. And I look at it always with a bit of embarrassment. And this is my nice address. Send it to me and I will reply you, and tomorrow we will discuss about the content. Okay? Many thanks for your participation. I conclude.